So this is precalc chapter 110. Today, guys, we're going to talk about slope. Slope affects all of us, okay? Slope is all around us. Every time you go uphill or downhill, you are going or moving or along a slope. What is slope? What are a couple different ways that we know slope as? What's it?
Oh, that's like the rate of change.
The rate of change, that'd be a good one. The rate of change. What else? Hearing some people say something. Kayla? Rise over run. What else? Steepness. Okay. I don't know if I spelled that right. Steepness. Right? Rise over run, rate of change, steepness. I think there was one more that I would personally, we would kind of have seen it as. How about delta y over delta x, which stands for change in y over the change in x. So, do we have any others that we were told along the way? Yeah. Delta.
Is the change in y over change of x, is that like y2 minus y1?
That would be the formula. I'll ask that next. So, let's just move on then. Slope formula. We like to use m for slope. Yes? I don't know why, but we use m. And the slope formula is... No, it's not y equals mx plus b. That is the point, our slope-intercept form. Y, 2, 1, over x2 minus x1. Does it have to be this way?
The y's always
the y's have to be on top because it has to be the change in y's over the change in x's. But could it also be y1 minus y2?
Yep.
But then I have to change the bottom to, whoops, x1 minus x2. So it's or. Either or, though, the arrangement of your points does not matter. You still will end up with the same slope. Okay? It just matters what vantage point you're coming from. If you're going from the lower point to the higher point, you'll have a positive slope. If you're going from the higher point to the lower point, you'll have a negative slope, kind of in a way, right? Mm-hmm. So it's the same slope from left to right, though. So, using the slope formula that we probably have above, could you find the slope between those 2 points? Now, that's not the only way. I could graph it and then find my rise or my run as well. But we'll just stick with the formula for now. When I use the slope formula, though, which point do you guys like to use for point 2 and point 1?
I like to use whichever one is positive.
Whatever one's positive. Yeah, so I like to technically take my bigger points or my bigger valued point as number 2 because I always subtract number 1 from it. And this way, I can't guarantee that I'll get positives, but I'll increase my chances of getting positive numbers, right?
Yep.
So, the formula is right above. So I'll say 5 minus 1 over 8 minus 2, and you end up with 4 over 6. Reduce that down, 2 over 3. So the slope would go up to 3 to the right. Not an issue. Most of us, if not all of us, have used slope about 500 times in the last 3 years. Yes? Can I turn? Now, where does all of this come into play? It comes into play the different forms of a line. I'm going to add one more on here that I forgot somehow. We also have standard. So, I heard some other people say y equals mx plus b. Which one is that? Again. That's the slope-intercept. That's the second one. What was point slope?
Isn't that the one that's like
Minus y1 equals? Yeah, x minus x1. Now, what they're going to do is more likely give you a point and a slope and tell you to write it as point slope. When you write it as point slope, you just fill in x1, y1 as your point, m as your slope, and leave it. You don't simplify it, you don't do anything. When we do simplify it, we generally get to slope-intercept form, which we're all pretty familiar with, graphing and all that stuff. Vertical lines. Vertical lines are all what? X equals something, right? I'm going to use H. What do you think horizontal line would be? Y equals K. Why would I use H and K? What do we usually use H and K for?
circle?
The vertex of a parabola, the center of a circle, an ellipse, all of those things. So it's an H value and a Y, X value and a Y value. Let's go to standard form next. Who remembers this? First hour had a little thinking to do on this one. Yeah, it's the A and B one. AX plus BY equals C. Now there are some limitations or some things that we should probably talk about when we are in standard form. They're minor details, they really are, but generally when we're in standard form, because we have an equal sign and it doesn't matter what A, B, and C are, they just have to be real numbers, we generally stick to what kind of numbers?
Whole numbers.
Whole numbers, a little bit better, we'll say integers, because they can be positive or negative, right? Whole numbers would just be with the positives. So integers, and, so you might want to put that, integers, and our x term, we like to have positive. That's about the only one that we generally say, hey, we like to keep this one positive. For some reason, it just kind of standardizes standard form. Is everybody okay with that? Then, move on to general form. And all we end up doing here is taking the C value and bringing it to the other side. Now, some of you guys might get a little upset with this. Mr. Concha, how can you bring C, which is positive on standard form, to the left side and it still be plus C?
Yeah.
Because do we know what C is? No, we're talking about forms. In this case, we're just saying that we're bringing AX plus BY plus C all on the same side. So A, B, and C, which are coefficients, real numbers, everything's on the same side, it's set equal to 0. We already saw this in a lesson or two ago with the circle equation where we had to use we had to complete the square twice to make it work, right? So pretty much any equation can be written in general form. It means everything's on one side, set equal to 0. Whoop-de-doo. So, for that next problem below, it wants you to write, it says the three forms, or all three forms. Technically, we could go as far as there's 4 forms. Okay? But I want not the standard form, we'll go to general instead. I want point slope form, slope intercept form, and general form of a line that has a slope of -1/2 and it goes through the point 1, -3. I'll give you guys a couple seconds to try that on your own. Put that in the video. When we're talking about general form, make sure that the same rules apply from standard form. Positive x value and integers for coefficients. So when I get to this, I think it's pretty straightforward to do y minus, y plus 3 equals -1/2 times x minus 1. So you're done. That's it. Leave it there. But the next one is, hey, put this in slope-intercept form, which actually means simplify it, solve for y. So, y plus 3 equals negative 1/2 x, because I distributed in, plus 1/2. And then the last step that I need to do is subtract 3. Guys, I am not going to put decimals with fractions. So 3 really ends up being what halves? 6 of them, right? 6 halves. And if I have 1/2 minus 6 halves, it's negative 5 halves. We got 2 down. I need everything on the same side. I need x to be positive. How can I make that happen? What's the quickest way? What's that? You could add 1/2 x to the other side. What's even better, maybe a little bit quicker than that? Multiply both sides by not just 2, but negative 2. Because when I multiply by negative 2, the negative 1/2 becomes a positive. So I'll get negative 2y equals x minus 5 plus 2y. Oh, it's a plus positive y. Yep, you're right. Plus 2y. So 0 equals x 2y plus 5. If I wanted standard form, I just bring the 5 to the other side, right? Any questions to that? What's the difference between part B and part A? You just need to find the slope first. Oh, wait a minute. We've done that already. What is a slope? 2/3? I think it was the problem from the last slide. And then you just have to choose, which point am I going to use? Does it matter? Shouldn't matter. But if I want to keep my numbers simple, I will use the smaller one. And so part 1 is y minus 1 equals 2/3 times x minus 2/3. Why did I say 2/3? It's x minus 2. That's one of them. Y minus 1 equals 2/3 x minus 4/3. Adding 1, but 1 will turn into what? 3/3. So it's 2/3 x minus 1/3. X is already positive, but I don't like the thirds on there. So I multiply by the LCD, which happens to be 3. I'm going to move this way up to the top. So I end up with 3y equals 2x minus 1 minus 3y. 0 equals 2x minus 3y minus 1, and we are done. So it's not too bad. Again, standard form, bring the 1 to the other side. Parallel lines have the same slope, perpendicular lines have. I like the opposite over negative, because if I say negative reciprocals, people think that it always has to be negative, but it doesn't. To be perpendicular, guys, one has to have a positive slope, one has to have a negative slope. Unless we're talking about a horizontal and a vertical line. Guys, wait a minute. Let me go back 2 slides. Let me just make sure we talk about this one more time. I went back too far. Here we go. Vertical line. What kind of slopes vertical lines have? What kind of slope does a horizontal line have? This is a m equals 0. Vertical lines, m equals undefined. So I just wanted to make sure to kind of talk about that real quick. Let's go back down to this one. So it's kind of interesting. Remember that because you can't divide by 0. That's why it's undefined. So I give you the fact that you're going to create a couple lines that go through the point 5, 2. And you need to create a line that's parallel and perpendicular through that point and be parallel or perpendicular to that line of 4x plus 6y plus 5 equals 0. General form of a line. You know it's a line because x and y both have a power of 1. So, what's the first thing I need to know for any of these? Slope. So, the easiest way to find slope of a line is to put it into what form? Slope-intercept form. So, that means subtract 6y. 4x plus 5 equals negative 6y. So the slope must be 4. Why not? You gotta get y by itself. Thought I could trick you. Y equals. Can we reduce it right away? So negative 2/3 x minus 5, 6. First hour, I left it as a plus 5 over negative 6, and they were a little upset with me. So I'll change it here. So, I mean, technically I'm divided by negative 6. It's a positive divided by negative, which makes it negative. So, therefore, this is okay. This is probably the best way to represent it anyways. What is the old slope? Old m equals. I call it the old slope, guys, because I'm going to change it, possibly, to a new slope for a parallel and perpendicular. But wait a minute. Is it really changing for parallel? No. So the new slope is still the same. And I'm using 5, 2 as my point. Now, it doesn't tell me what form to put it in, does it? So what are you going to default to? Slope-intercept. You guys are most comfortable graphing slope-intercept form. Let's just stick with slope-intercept form. So, to get the slope-intercept form, I'm going to use point slope. Y minus 2 equals 2/3 times x minus 5. This is for parallel. What happens if I want to be perpendicular? So it'll be y, oh wait, m is what? 3 over 2. I'm going to take the reciprocal and change it to a positive. So therefore, y minus 2 is 3 halves x minus 5. You guys can finish it out. I'm just going to leave it here for now because this saves time. Now, there are some things that are going to be different about this, like the y-intercept. Why is it different? Because here it's a negative 2/3 times a negative 5, which makes a positive number. But if you go down here, it's a 3 halves, which again is a different number, times a negative, which is negative. Everything else is the same. I'm going to add 2 to both sides. So you know they're going to have different y-intercepts. They very well could have the same y-intercept, couldn't they? But we're not going through that same point. We're going through the point they have in common at 5, 2. If you take your two equations here and did a system, found out where they intersect, you'll end up with 5, 2. Wouldn't that be funny if I put that in a quiz? be like, hey guys, create an equation through 5, 2, and then say, hey, take your two equations and solve for the point of intersection. How many of you guys would recognize right away that they have to intersect at that common point for them to be perpendicular to each other? They're using a common point to find the equation. That means they have to go through that common point. Any questions? And I think this, might be one or two more after this. Okay. Show that this guy's points P, Q, and R are vertices of a right triangle. I like this question. I like this question because it makes you think. Before we do anything, what am I looking for? A right triangle. How can I prove something's a right triangle? Something with the slopes. The slopes have to be opposite reciprocals of each other. But it's not every single place, right? So that means what I need to do for this to get this. Take the points and before you do that, you have to graph it. So what if I did this real quick? Made a very, very crude drawing to see, going by 5s, because we can definitely tell that our points are not all going by 5s. But if I make something that allows me to get the general shape, I should be able to look at it and say, hey, my right angle should be this one. Right? 3, 3. That is P. Then we go to 8, 17. Q. And the last one's 11, 5. That's R. So if I go to draw my, where do you think, what angle is your right angle? R. Everyone say it together. R. Okay, sorry. Thought we'd all be like pirates today. So that means you just have to find the slope of, not all at once. Find the slope of QR and PR, and they should be what to each other? Opposite reciprocals. So PR, slope between those two. Five minus 3 over 11 minus 3, which is 2 over 8, which is 1/4. Okay, not bad. And then now we need QR. QR, I'm going to do 17 minus 5. That's a way bigger number. Okay. And 8 minus 11. 17 minus 5. Over. -3. Ooh, we know it's going to be negative. And 12 divided by 3? Are they opposite reciprocals of each other? Therefore, wow, that's bad points. Therefore, PQ triangle, we say PQR is a right triangle, or is right. Now, we possibly then could also go for the fact that, can I guarantee that this is an actual right triangle? Or can it even form a triangle? I guess we have to catch a triangle. Never mind. This would work then. I was even thinking about first hour, should I have to prove that this distance squared plus this distance squared is equal to that distance squared? You know, using Pythagorean's theorem to make sure that it works out. It's another way, right, to kind of show that it's a right triangle other than slopes.
Wait, did you write R?
Did I?
No.
I did R, Q, R. I just wanted you guys to say R. That's all. Make that one a P? I don't know. PQR. Okay. Last problem, I think. Oh, no, it's not. I lied. Shouldn't lie. I was kidding. Joking. A dam is built on a river to create a reservoir. The water level W of the reservoir is given by the equation W equals 4.5 T plus 28, where T is the number of years since the dam was constructed, and W is measured in feet. Sketch a graph. I think you guys can all do that in about 4 seconds. At least I hope so. So we go here, 5, 10, 15, 20, 25, 30, 35. Maybe that's not going the best. So I'm going to go by 5s, but I'm still going to go by 1. Number of years on the bottom goes by 1. The top goes by 5s. So I got to start at 28, 5, 10, 15, 20, 25. So 28, somewhere about here, which means I have to go up 4.5 and over 1. It's not going. Somewhere about there. And then I'm going to do it again. And there it is. Notice I didn't put an arrow on the backside. Why? The water level was it stayed at that current level until they built a dam, and after that, the water level started increasing. Right. So there's your graph. Hey, it's a positive slope, which means that the water level is going up. Okay, that's good. What does the slope mean? What does the W-intercept mean? It's not a y-intercept, it's a w-intercept this time. We'll start with the intercept. What does the intercept mean? Yeah, the water level, right? The w-intercept is the water level at 0 years. So that's the time that the water level, or the depth of the water, when it first started. What is the slope mean, though? Yeah, every year, the water increases 4.5 feet. That's a rate of change, right? Got there. So it goes up 4.5 feet for every year change. It might be a better one to say that as well. That's all I'm asking you. Just kind of break the problem apart and explain what it means to have a rate of change. This one, same thing. I'm not going to actually graph it. But what does the slope represent? When you get to the height of 2.5 kilometers, what's the temperature? As dry air moves upward, it expands and cools. If the ground temperature is 0 degrees Celsius and the temperature at the height of 1 kilometer is 10 degrees Celsius, express the temperature T in Celsius in terms of the height in h in kilometers. Assume this relationship is linear. That helps things out. Some things we need here. You need a slope and you need an intercept. Do you happen to have any of those? Thank you. What are some data points? 0 kilometers high. The ground is 20 degrees Celsius. There you go. What's the other point? 1 kilometer up. 10 degrees. Hey, we can find a slope from that. M equals 20 minus 10 over 0 minus 1 equals 10 over negative 1, which is a negative 10. Hey, right away, might as well just explain. What does that mean? Yeah, there's a 10 degree, right? 10 degree, that's not a 6, it's a 10. 10 degree drop for every 1 kilometer rise. Right? Basically what it comes down to. That's what slope means. And then, can I create the equation really quickly and efficiently with this information? How many people recognize that we know the y-intercept? It's what? So t is equal to negative 10 h plus 20. Because 0, 20 is a y-intercept. There it is. Any questions for that, guys? Just to understand what it means when you have a rate of change. So, we've got to answer the question, right? Now we have to answer what happens when you go 2.5 kilometers up. Just plug it in. Negative 10 times 2.5 plus 20. Equals negative 5 degrees Celsius. It means that if you have a height of 2.5, or you are in a hot air balloon 2.5 kilometers above the ground, the air temperature will be a negative 5 degrees Celsius. That's freezing. It's kind of cold. Homework, page 124, 1 through 73, every 3. Have a great day. Sorry, that was every 4.